Hi everyone, today we're going to continue the series on Wordle. The idea here is that we want to create a Haskell application that will, when we sort of tell it that where we are in a Wordle puzzle, it'll analyze what is the next best guess that we can make, and it's going to do that by trying to figure out which guess is likely to eliminate the greatest number of words out of possibility. So that's our goal. There's been several videos so far in this series. You can find a link to the playlist down in the description. But we're going to sort of jump into where we are. Today's video is going to be about coming up with a way to represent the state of a Wordle puzzle so that we can then use that to filter down the list of all possible words down to just the list of words that are sort of still in play. Okay, so last time we got everything working. We have now a way of representing all of these words. We have a list of final words. That's going to be what we're going to be focusing on today as a vector. In other languages, that would just be called an array of text, which is a nice, convenient representation for strings. Okay, so with that, now we need to start doing some analysis on these. So I'm actually going to do this in a new file. So let me over here, where do I go? New file. And this, well, I'll call wordle.hs. And then let's see. So what are we going to do here? The key thing is that I want to think about a way of taking this general list of words and filtering it down just the list of words that are still valid in a certain play of the game. But to do that, we need to know, what do I mean by a valid or what do I mean by in a certain state of the game? So the first step here is to define what the state is. And this is going to be something over here. We'll figure out what in a little bit. And then we can write a function, filter words, which takes the state and then some existing list of words, so vector of text, and then it's going to give us a new vector of text that's the filtered words. So I can put this in as just undefined. We don't know what it's going to be yet, but we're going to have something there. So now we have to think, well, what do we need to store? Well, at any given point in a Wordle game, there's a certain number. We have characters, and those characters are forbidden from appearing in certain places. So we might know that a character isn't in the word at all, that we've guessed that character or I should say letter in a certain word, and we got a sort of a gray box in Wordle. So that means that's completely eliminated. Or we get a yellow box, which means that it's eliminated from that one spot, or we get a green box, which we could say it's eliminated from all of the other spots. And because over time we might slowly eliminate, if we get a yellow in the first slot and then a yellow in the fourth slot of a Wordle, for the same letter E, say, then we know that E can't be in the first slot. We know that E can't be in the fourth slot. So we sort of build up this list of places that a letter can't be. So I'll sort of write that out. So for each letter in the alphabet, either we know nothing about it at all, we haven't guessed it ever, it's not in the word, or it's in the word, but not in some spots. And maybe it's not in one spot if we got a yellow indicator, or maybe it's not in 4 spots if we got a green indicator, but we can phrase those as sort of two of the same thing, right? We can almost think about it as this. In Wordle, if you guess the letter E in the first slot and then the second slot and then the fourth slot and then the fifth slot, and you get yellow, 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 well, that means the same thing as if you got green on the third slot, right? So we should be able to, we want to represent this in a certain way that where these two things are represented the same because they really mean the same thing. So the way I can think about this is that really what we have in a state is, here mixed state is the constructor for the state. Now I have to say what's actually stored there. So what we have in a state is we have a mapping from characters to sort of information about that character. And because we don't want to just we're going to start out with an empty map, we're going to say that we know nothing, not in the state map. we're going to say that if we don't know it, we're not going to store it in the map at all. And then these other two cases, we're going to store as separate kinds of entries in the map. So let's see what I mean by that. So here, the state, I said it's going to be a map from characters to, well, sort of to letter information, I'll call it. And that's going to be some other type. So then we can have data letter information. And letter information, there's two different possibilities. Either it's letter not in Word at all, or letter not in locations. And then we can list what locations it's not in. And what would this be? Well, I guess the list of locations, we could use a list, but it's a really more set-like. Right? We're going to accumulate different spots where the letter can't be. So this is going to be a set of location. Okay, let's start actually seeing about getting this to compile a little bit. Can we try to load this? And somehow HLS is not activated here. Maybe I haven't added it to the Cabal file. So other modules here, words and Wordle. And then this is still, so that made other things turn red up here. Should I just restart the LSP server and see what happens here? I'm expecting errors because there's errors in this file. Okay, here we're getting something. Oh, that went away. Let's see. We're not, for example, map isn't imported here. So we're going to have errors. Well, HLS is not working for us today. I don't know why. We're not going to debug that live. So what I can do down here is I can now say Cabal REPL, and that will try to load things up. And indeed, we're gonna get some trouble here. And that's because there's a bunch of things that I haven't defined. So we can start working our way through these errors here. So first is that we don't have set, we don't have map. So we're going to have to import these. Well, it turns out that the modules, so if I say import data.set, that gives us sets. That's very good. But it doesn't, rather, the data.set module exports a lot of functions that share names with functions from other places too. So the best way to import data.set is qualified. So that means that every time we refer to a set operation, we have to say s dot. So we're going to have to say s dot down here. And then we're also going to import qualify data.map as m. Data.map does the same thing. It reuses a lot of names of things. So we're going to say this is m.map. Vector does this also. So data.vector is going to be v. And of course, not to be left out, text also does this. So text is going to be t. So we have to put these little prefixes. Okay, so hopefully that solves a lot of things. Let's try to reload down here. Oh, could not load this module. It is a member of the hidden package. That means we have to add the package containers here. So we have some packages already. So we're going to say containers. Anything after 0.6, I'm sure will be fine. Oh, wait, this is turned red. Maybe HLS is trying. I don't know what's going on. Let's just plow on without that. Let's try to reload this again. Oh, but we have to restart this because the Cabal file changed, so we can run Cabal REPL again. And it's compiling words. Oh, and now we just don't know what location is. Let's just on a lark, let me just see if I look at errors. What are we going to have here? Failed to parse the result of calling Cabal. I've seen this before. There must be something strange. This has to do with Cabal is like compiling for the wrong Mac OS backend or something, because I have a newer Mac and this is somehow configured for an older Mac. I don't know why exactly. I'm not going to debug that now. Okay. You know what? I'm just going to try one thing. Maybe this will do it. Maybe if I do Cabal clean, and then if I look for other things in here that might be telling, no, there's no sort of funny HLS-y kinds of things. Let me just look out here briefly if there's any weird HLS-y kinds of things. No, I don't see anything. That's not going to work. Because there's every now and then I see a folder called HIEBIOS, which has some stuff in it that sometimes gets mistaken, but that doesn't seem to be the case here. So I'm going to give this one little restart. I don't want to do any of these things. Restart Haskell LSP server. Let's just do one last try, and then hopefully something good happens. No, we're getting this weird failed to parse the result of calling Cabal. Okay, so let's give up on HLS for today. Instead, I can say Cabal REPL down here, and that should hopefully load things. Okay, we don't know what location is. Well, that's very true. We don't know what location is. So what's a location? It's just going to be an int. This int, whenever I make a type synonym, there should be sort of a semantic meaning for that type synonym. So in this case, type location equals int. It's really going to be saying this is an int in the range 0 through 4. Because it's got to be one of the locations in a Wordle word. And following much the frequent tradition in computer science, we're going to be 0 indexed. Okay, so if this is our state, so we have letter information, a letter is either not in a word or it's not in specific locations, where a location is just one of these numbers in the range 0 through 4. So now I've described what my state should be. And then, now, given that state, I should be able to go through the list of words and see what words we don't we've eliminated. And then this is all going to be part of figuring out how many words we've eliminated and sort of building up all of these other things, right? So it's sort of one step at a time. So this filter words is going to take this state, and then this, I'm going to call this a mapping, and then the list of words. And let's see, what is it going to do? Well, it has to return sort of the result of a filter. So I want a filter function. Let's, if I type this, do I get, yeah, there we go. So I want a function that takes well, let's just go to data.vector dot filter. Aha. So here we have filter, which is going to take some function from A to bool, and it's going to take a vector A to a vector A. That's excellent. That's exactly what we want. And it's going to drop the elements that do not satisfy the predicate, and it's going to do that in O of n time, where n is going to be the length of the vector. That's exactly what we want. Good. And I apologize if my face was blocking some of that. I should be aware of that. Okay, so we're going to say v.filter, because we're doing a vector filter here. And then I'm just going to write predicate, and then over what words? Well, over those words there. So now it's incumbent upon me to write out what this predicate is. So predicate has to be a function from text to bool that uses the state to figure out whether this is, whether this particular word is still valid. So now let's think. How are we going to do that? Well, we have to essentially go through each letter in the word, and then for each letter in the word, we are going to we're going to see, does it sort of agree with the letter information? And then that should do it. So what I really want to do is I want to have some process that goes through each letter and then checks each letter. So I don't know off the top of my head what that's going to be. So let's look at the documentation for data.text here. So let's look up data.text and see what we can find. So here's data.text. And, one thing that we should think about, strict versus lazy types. Let's see. So we want the strict type is provided by data.text. The lazy type is data.text.lazy. This is something we should be thinking about. So many data types in Haskell come in both strict and lazy versions. And in our case, we're really always going to want the strict versions of all the types. So luckily, the strict version comes from data.text. That's what we're using. Although this makes me think about the fact that we should really check this for our other data types. So let's do that really quickly. So if I look up data.vector, let's see. So data.vector, let's see, boxed vectors. Does it say anything about this? This talks about mutable and immutable. It doesn't really talk about lazy. Let's see if we look at the contents of the package. Is there a data.vector.lazy? No, it doesn't look like it. So I think we're okay here with vectors. Maps and sets, I know, come in 2 variants. So we want to make sure to get the strict variant because we're going to be using all of the data that we build up here. So you should use data.map.strict instead of this module if you will eventually need all the values stored. That's pretty good. That's what I want. So let's go into my code and make that change right now. So this is data.map.strict. And then let's also look at data.set. And data.set here, let's see. It represents a set. This doesn't really talk about lazy versus strict. If I look at the table of contents, is there a lazy? Oh, so there's data.map and data.set. There's only data.set. Okay, so I don't have to worry about strict and lazy here, it looks like. Excellent. Okay, but we did get the right kind of map. But that's not what I was trying to do. I was trying to look at data.text and to find a function that would sort of go through all of the characters and then figure out whether the word is still good. So, folds. So this idea of going through every element of a collection and sort of accumulating some result by inspecting every element of a collection, that's called a fold. And so here we get to we have some state, and then we get one character at a time, and then we can process that character. And then we'll produce some other state. That's exactly what we want. Well, I say exactly what we want, but actually, as I'm thinking about it, it's not exactly what we want, because the location of the character in the string is going to be important, right? If I only have the character, if I know that X appears, that's not enough information, because I need to know where it is in the word to be able to sort of look at my locations and see if the locations are right. So let's see if we can find a function that does that. So there's a lot of things with characters, but I'm looking for something involving an int. But I don't see any here. So that's a bit strange. And let's see. Well, another way that I could think about it, if I don't have a fold like that, maybe I can do something where I do a lookup. Let's see if we can sort of look up in a text and then extract out the character from the text. That's another way of doing this. So that looks like indexing. So index, this has the right type. So a text, int, and then it returns a car. But this is very, very interesting. This means that every time I extract a single character from a text, it's going to take a linear amount of time. And then if I look up here, if you think of a text value as an array of car values, which it is not, you run the risk of writing an inefficient code. Well, that's a shame, because that's exactly what I'm doing. So this suggests to me that text is not actually what I want. And that kind of makes sense as I'm thinking about it, because this text type is optimized for large chunks of text. Not that we analyze, but we probably do a lot of composing and copying and printing out and things like that, but maybe not analyzing character by character. And in the end, I don't need to do any of these very texty operations. I really just want a vector of characters. So I think in the end, I chose the wrong representation. So we might wonder how this affects my memory footprint, but I'm not going to get back involved with that today. So if I go over here, I don't want this anymore. I've changed my mind. I don't want this to be a vector of text. I really want this to be a vector of character. And then I want to do that down here for this one as well. And then where this inner vector, well, gee, those are always going to have length exactly 5. And so that makes me think about, wouldn't it be nice if I had a type that always stored exactly 5 elements? But I'm not going to tackle that problem today. There will be a future video where we go back and try to make these types a little bit more specific. But for now, we're just going to know that these always have length 5. But you know what? Something tells me I'm going to have a bunch of these. So let's make a new type, vec5. And it's just going to be vector for now, but there's going to be an invariant, always exactly 5 elements. Never more, never fewer. And then so here I can say that this is not just a vector, but this is a vec5. And then, whoops, it's hard to find this spot. And then this is also a vec5. Right? The outer vector is not a vec5. There's many elements, but each of these inner ones is a vec5. Okay, let's just see about that and see if we get ourselves into trouble. Oh, predicate, there's a parse error over here somehow. Oh, I've just said predicate equals. Let's just say that's undefined for now. And we'll try to reload here. Oh, we're getting some kind of error. Ugh, I'm really missing HLS. I have to somehow get that working again. No instance for isString vector car. Okay, so over here in words, we're using overloaded strings. So what that does is that every time I write a string, it uses type inference to figure out what type that string is meant to have, and then it tries to sort of convert the string from its internal format to that other format. Well, to do that, we need to have an isString instance, but there isn't one for vector car. I don't want to define one for vector car because that would be what's called an orphan instance, in that it might conflict with other isString instances that someone else might write for vector car. So I don't want to do that. Instead, I think I'm going to sort of define a new type here that's going to be isomorphic to this vec5 car, but it's going to be a fresh type. So let's see, new type word equals, we'll call it mcword of vec5 of car. And by making this a new type, it allows me to define instances. So now, instead of vec5 car, this is going to be a vector of word. You know what I'm going to do? I'm going to change this up here so I have to stop scrolling down. So this is final words and guess words are both going to be vector word. And then I can get rid of this other type signature here, so I don't have to bother with that anymore. Okay, let's see. What do we think of that? Yuck, all that scrolling. Oh, ambiguous occurrence word. Right, there's a built-in thing called word. So this isn't any word. This is a Wordle word. And let's load that. Okay, so now it like that, but now I'm sure it's going to complain about, whoops, there's no instance for isString. So it looks like that comes from the data.string module. So let's import data.string. And now that I have this new type, I can write an instance isString of Wordle word. And then now I have to define this conversion. I don't know how to do that off the top of my head. So let's use GHCI to query that. So if I import data.string down here, then I can get info on isString. And isString, it has this function from string, which just converts from a string to this other thing. So that sounds good. So from string. Now, a string here is going to be a list of characters, and I want to convert a list to a vector. So let's see if we can find over here a conversion from a list of something to a vector of something from list. Excellent. That's exactly what I want. And I can see that this is in data.vector. So if I say from string, actually from string can be exactly from list, I think. Oh, this will create a vector of car, but it won't create a Wordle word. So I really want to say from string cars is mcword of from list of cars. Okay, let's give that a try. Oh, now we still have an error. What's the error? Whoops. No instance for isString word. Oh, aha, I haven't updated this down here to Wordle word. Let's reload. Aha, that works. Excellent. Okay, and let's see, this Wordle thing also presumably worked. Okay, so I said, all of this was about getting rid of this t.text. So now this is really a vector of Wordle word, and this is going to be a vector of Wordle word. Okay, so far so good. So now that it's a vector, let's look at the documentation for data.vector here and see if we can find the right kind of fold here. Probably should have looked for this before converting. So here fold, this is pretty good, but again, it doesn't give us the index. So let's see if we can find one with an index. Aha, I fold L. So this will work our way left to right, where the index with this int is going to give us the index of the letter that we have at the current moment. That's exactly what we want. Except here, we want the strict version because we're actually going to be computing it and using this value. So we want I fold L prime. Excellent. Okay, so over here, let's see, how can we get I fold L prime in the act? Now I'm going to have to import data.vector. Let's import it qualified. Oh no, what's going on here? That was very strange. I know what's going on here. Oh, this is a bug in this binary thing. If silly things. I know how to fix it. The answer is if I have to say term equals dumb cabal REPL. This has to do with a weird incompatibility with the binary that's posted for newer Macs and the way that terminals work on newer Macs. Very silly thing. But the workaround is that if you say term equals dumb, then things will work better. Okay, so if I import qualified data.vector as v, now I can remind myself easily about, not ifold L prime, v.ifold L prime. And I think this is going to have the right type here. So what do I want to do? Here, this is no longer a t.text. This is a Wordle word. And my predicate, well, I need to get so this is the word. So what I'm going to do is I want to call v.ifold L prime with some function, which I'll just call go for now. And what is it going to operate on? Well, I want this to start out, if before I've looked at any letters, then I can't eliminate the word from contention. So before looking at any letters, then I'm going to say true, this word is okay. And what's the vector of letters? Well, it's going to be this word. Okay, good. And now all I have to do is define go. Well, go here is going to have something that looks like this type. But A in this case is the result that I'm producing. In my case is a bool. So this first argument is going to be sort of the thing that we've measured so far. Are we, given what we've looked at so far, is the word going to be included? Then we're going to get the index. Then we're going to actually get an individual character. And the reason I know that is because a Wordle word is just a vector of characters. And then it's going to produce a bool. Okay, so go, this is sort of a judgment so far, we'll call it. And then this is the index, and then the letter, and then we have to produce a result. So if judgment so far is false, well, then we're done. I don't need to do anything else. If I know I'm eliminating the word, then I'm eliminating the word. So that one's easy. If it's true, now we have to do some work. So if this is true, so now we have a certain index and a certain letter. Well, now what I'm going to do is I need to look up that letter in my mapping. So we're going to do case, now I need to get the right function to do lookup. So is it called lookup? It probably is, but I want the mappy one. Oh, here. So here we pass it the key, which in my case is a character, and then the map, and it'll give us a maybe A. Excellent, that's just what I wanted. So case m.lookup, the letter in the mapping, that's this mapping up here. And this is either going to be nothing. That means that the letter hasn't been seen before. So if the letter hasn't been seen before, then we can't eliminate the word. So that word is still a good word. If the letter has been seen before, well, then we're going to get some letter information. And here, so if we have just info, let's see, just info, what are we going to do now? Now we have to look at the info to figure out what the info is. So then this is going to depend on the info. So I can just do a nested pattern match here. So if we get just letter not in word, well, now we're in a case, we see a letter that we know is not in the word. Reject. False. So now we know this is the case where we've guessed the word peach, and we got a gray response for the letter E. That means E isn't anywhere in our word. Well, now every remaining word with an E in it is eliminated. And that's what this is saying. If we see that just that the letter is not in the word, then we're going to return false. Otherwise, then we get this set of location. Otherwise, excluded locations. Ooh, that's confusing, isn't it? So this, I really should comment this up here. Set of places letter cannot appear. Okay. So we have our excluded locations. Oh, it strikes me I could just sort of get rid of that, and then I'm less likely for my face to get in the way of things. So here, hopefully everyone can see that now. So now if I have just excluded locations, I have to see, is the current location in the excluded locations? So once again, let's look here. So this is going to be a function that takes in a set of A and an A, and we want to see if A is in the set. Oh, we're getting these funny Unicode-y things. I don't want to worry about Unicode-y things. Member, that looks like the right thing. Data.set, and it's called member, and we say the thing and then the set. Excellent. So we want to see, is index, the current spot that we're looking, is that a member of excluded locations? And now we can get rid of the spotlight over here. And if it is, if it is, then the word is bad. If it's not, then the word is good. So we're going to say not this. Is that everything? That might be everything. Let's try it out. So let's reload. Oh, not in scope, Wordle word. Oh, did I not import that? Oh, I have to, of course, import words. That's important. Reload. Okay, now it's going to recompile words. And then we get some errors. So let's start working our way through the errors. So line 27 here. Couldn't match v.vector car with Wordle word. Oh, that's because word is not actually a vector of characters. So I'm going to go over here and say we need an accessor function. So we're going to call this get letters, which goes from a Wordle word into a vec5 car. And get letters just unwraps. It's just going to return the letters. Okay, so then now over here in Wordle, I can say instead of word, this is really get letters, because we're going to stop considering this as a word, but really start considering it as a vector of characters. So let's see if that's any happier. Okay, so now couldn't match set int with actual type letter information on line 36. Oh, that's because it's not just excluded locations. It's just letter not in locations. And then we get the excluded locations. Okay, good. That works. So now what I'd like to do is I'd like to test my filter words. I want to see, does this actually do the thing that I want it to? So to do that, I need to have a state. So let's, I'm going to call it Peach State. It is not Georgia. That's a United States state reference. The state of Georgia produces a lot of peaches. That's sort of one of its bits of reputation. So a peach state is going to be a state. And this is going to be, suppose we get, I don't know, no P, no E, A is in the word but not here, no C, and then H is in the word for a guess of peach. So I'm using X here as notation for not at all in the word. This is we get a yellow indication, we get a green indication. So this is going to be mixed state of, now we have to produce one of these maps. So I have to figure out how do we produce a map. So if I go over here, I can look at the map documentation. I want data.map.strict, don't I? Yes, I do. Construction, and this is going to be from a list. That's a convenient way of constructing a map. So I just have to give it a list of pairs. I can do that. Excellent. So it's right here. So this is going to be m.fromList. And now, what do I know? I know that P is letter not in word. And then E, everything is going to be lowercase because all of the sample words are in lowercase. E is also not in word. And A is not letter not in locations. Oh, now we need to make a set, but I bet that's also from list. And the only location that A is not going to be in is location 2, right? Because it's the third letter, so 0, 1, 2. Then C is letter not in word. And then H is letter not in locations. And here we also have to do this, but now it's not in locations 0, 1, 2, or 3. It's in none of those locations. And that should be my state. So let's see, does that compile? It does. Wow, okay. So now the real question is, what happens if I filter words using the peach state and the initial final words. What do we get? We get variable not in scope filter words. I think I need to import Wordle. And let's try that again. No instance for show Wordle word. Okay, well that makes sense. So I made a new type Wordle word, and I haven't said how I want to print it out. So I'm going to say instance show Wordle word, where I don't really want quotes or anything like that. Let's just sort of print it out. So where show of McWord letters, so this is going to be a vector. I want this to I want to convert it back into a normal string. So that's probably toList of letters. Maybe. Seems plausible. Let's give that a try. Hasn't complained yet. That means it's going to work. Okay, so we've done that. Let's try my query here. Ooh, it did something. So it's saying that now with this Peach state, with this fact about Peach, then we only get these possible words left. So notice we don't see a P anywhere. We don't see an E anywhere. But something's funny. I was expecting each word to end in H. But they don't. What's going on here? In fact, I don't see any H's anywhere. That's very strange. So as I'm thinking about it here, and the other thing is, we need A not to be in the third spot, but we need A to be somewhere. So I think what's happening is that I've said that A can't be in the third spot. H can't be anywhere but the fifth spot, but I haven't said that they have to be anywhere at all. So I've made a mistake in my representation here. This is not quite enough information. Or it is enough information, but I guess I'm applying it incorrectly. In that not only do I have to check to see that that I'm not sort of violating any of these location things, I have to check to see that all of my required letters are actually represented. So there's really two separate checks that I have to make on a word to see that it's valid. I have to make sure that no letter is in the wrong spot and that the letters are good. So this particular predicate that I have now, no letters in bad locations, that's really what it's checking. But I actually need not just that, but I need no letters in bad locations, and I also need all required letters. So that means I need to make a new predicate here, all required letters, which takes in what is this? This is also going to be a Wordle word to bool. And all required letters word. Well, what does this want to say? So I need to figure out what are the required letters. So let's first compute out the required letters. So the required letters, I need to go through everything in this mapping and then find every mapping that maps to this letter not in locations. Okay, I suppose, let's see what data.map gives us for that. This is kind of a query. No, this is a traversal, I think. Oh no, that's map. I don't want to do mapping. Maybe, no, this is a fold. That's what this is. And I saw that there was another link for a strict fold. So here, we're going to have to fold over the map, and we don't really, do we care about the keys here? Oh, we do care about the keys. So we need fold with key, and I don't think it really matters whether we go left or right. So I'm just going to choose left because I kind of like thinking left to right rather than right to left. So we want this fold L with key prime because we also want it to be strict. So to get the required letters, I'm going to use the map fold L with key prime, and I'm going to do import qualified data.map as M down here so that I can get M dot, fold L with key prime so I can see its type. Okay. So here it's going to take some other function. I like these functions are often named go. So to prevent them from sort of leaking, I'm actually going to take this one and I'm going to indent it some so that it's really part of this no letters in bad location, so that I can write go here again and it's going to be a different go. And then the next thing I need is A. Well, what's A? A is sort of the value I'm producing. Well, in this case, it's required letters. That's going to be a set of letters. So here I want an empty set. Let's look at the documentation for set. Here we go, data.set. This is sort of construction empty. It's called empty, haha. So I can say over here, go s.empty, and then the map that I'm working with. Well, this is my mapping that I took in as an argument. Okay, good. And now go, I don't have to write out its type, but I will to just sort of keep myself remembering where I'm going here. So this is going to be a set of characters that are required, and I need the key to the map, which is going to be the character I'm considering, a letter information, which is the value in the map, and then this is going to produce an extended set of characters that are required. So this is already required, current character, a current letter, and then information. Well, if the information is letter not in Word, I don't need to do anything. I don't want to extend the set of requirements, so I'm just going to return already required here, and to avoid a warning around unused variable, I'm just going to put an underscore there. Here we have already required, current letter, letter not in locations. Well, actually, it doesn't matter what locations it's not in. If it's a letter not in locations, it's definitely going to appear in the word. So I can just sort of use empty braces to say, I don't care what other information is stored here. Now I want to say, I want to extend this set with this new current letter. How do I do that? Data.set. I don't want construction anymore. I want insertion. Insert. We take the thing and then the set. Okay, that's easy enough. So I can say current letter s.insert already required. Okay. That may work. I don't know. Let's give it a try. Let's load. Now there's, down here, I haven't finished writing this function. So now that I know the required letters, let's see. So now that I know the required letters, what I want to do is I want to see if the required letters are a subset of the actual letters. So do I have a subset operation in data.set? Let's see. Generalized. Let's just see. Do we have subset? Ah, excellent. Is subset of. Just out of curiosity, what category is this in? Query. Okay, I guess it's a query. So is subset of. That's what I want to say. So I want to say, are the required letters is s.is subset of then the letters in the word. So letters in Word. So now I have to create a set from a vector. So let's see, how do I do that? I bet that's going to be some kind of set operation. So this is construction, is it not? So I can say from list, from ascending list. These are all listy things, power set. But I don't have a list, and I'd rather not create an intermediate list. So really, I guess what I need to do is I need to do a fold, because what I'm going to do is I'm going to fold over all of these characters in my vector. So now I need to do a v.fold, and it's going to be another strict one. Let's just go back over to vector. And so here we're going to have fold L prime. And let's see. So let me just get here the type v.fold L prime. So v.fold L prime of some function that's going to combine this. So again, I'm going to call it go. And then it's going to start with an empty set, and it's going to fold over the letters in the word. This is getting a little confusing. And then here, my go function is going to, let's see, this has to take an A, so that's going to be my set of characters. And then my B, that's the thing stored here. Whoops. And then it's going to return a new extended set of characters. So old set car, well, it's just going to insert the character into the old set. Oh, look at this. So what I can do now is I can rephrase this as s.insert of car old set. And so actually, instead of defining go, I can just say flip s.insert, where flip is a nice Haskell function that just takes a function and alters and swaps the order of its arguments. And what that will do is it starts with an empty set and we'll sort of insert one letter at a time. I think that should work. Let's try to reload and see where we get. That did work. Okay, so, and then did I use this new function? Yes, I used this new function up here. Let's try my filter operation again. Wow, look at that. So by guessing the word peach and eliminating the P, the E, the C, knowing that A can't appear in the middle but has to appear somewhere, and that it ends in H, I'm left with only 4 possibilities. So that's very powerful. Okay, so what have we done here? I think we're going to wrap up for today. What have we done here? We've defined these sort of central data types trying to represent what does it mean to be in the middle of a game of Wordle, and then defined this key operation which allows us to take our big list of words and whittle it down. There's going to be a bunch more stuff that we're going to have to do. And another thing that we should be thinking about is this efficient? Is what I've done actually efficient here? So in some ways, yes, but I'm actually worried in the back of my head, there's only ever 5 elements. Is a set really the right thing? Sets, are good asymptotically, but do we really need all that power here? We'll find out. Thanks very much for watching. Hope this has been fun. So long.